Okay, so I'm going to outline the important ideas from 3.4. 3.4 is all about the margin of error. But before we get to that, we have to talk about some notation. So in this unit, we're going to talk about the proportion. So the symbol for a proportion is P. A proportion is the ratio of our identified statistic in relation to the whole. Now, if you'll remember from last unit, we actually do something different when we take a sample. So if I took a sample of 100 students in Rockbridge High School and asked, I can't think of an example on the spot, but if I ask something, the proportion that I get is going to be P hat because it's a sample. This is not the population proportion. The proportion of a sample would be how many have that characteristic, would go here, divided by our total. And generally, we would end up, we put it into a percent. So you'd get a decimal if you actually did the division, and I think you all know how to transform that into a percent. So as we go on, when we're talking about proportions, you need to understand that the proportion is the ratio of whatever we're looking at out of the whole. Now, what is margin of error? So margin of error is an estimate that describes how far, at most, we would expect our statistic to vary from the true population value. So it's impossible to make this zero. If we are taking a sample, the only way to not have a margin of error is if I genuinely survey the entire population, which is not realistic. We can't do it. So no matter what, we're going to have this margin of error, but we can minimize it, right? So it's okay that we have it. It's not wrong to have some error, but we account for it. So when we make interpretations and inferences, I'm not going to do an example in this video, but we will talk in class. We'll calculate it, and then we say in context something about we got this as we think the mean is this, but with our margin of error, the true population is going to be between this and this. It'd be an interval using that margin of error. So you actually see this, I'd say, the most in statistics. So a lot of times in polling statistics, they'll say so-and-so's ahead by this many points with a margin of error of 2. So that means that they got this estimate, but it could be anywhere from 2 below that value or 2 above that value. So I'd encourage you to maybe go look at some statistics like that and see if you can interpret what they mean in context, because it's a very important concept that a lot of people don't understand when they're looking at statistics. So now the formula, I know you guys have been waiting for some hardcore formulas, and here you go. I've got one for you. So how do we calculate the margin of error? I abbreviated it MOE, so hopefully you can remember that. The margin of error is 2 times the standard deviation of simulated samples. So we calculate a sample mean, a sample statistic. We get the standard deviation for that sample statistic. So the margin of error is 2 standard deviations above and below that. So we've got the interval here is the mean. So the symbol for the mean is X bar plus or minus. So this means that we actually end up with 2 values from this formula. And the symbol for margin of error is just an E. I don't think that we touch on it in this course, but if you're curious, it's an E. So what we would do is we would take our mean and we would subtract 2 times the standard deviation of our sample. We would get a minimum here. And then we would add the mean plus 2 times that standard deviation, and we would get a maximum. So the interval, you'll pay attention to the wording here, we get a minimum and a maximum. And so in context, we would say, based on our sample, we think that the true mean, if that's what we're looking at, would be between this value and this value.